Today, we're going to continue talking about lines. That's the major topic of this chapter. But we're going to talk about the relationship between lines that are parallel and lines that are perpendicular. So, what do you notice these two equations have in common? So, Brenda? So, and Shirley, what did you say?
The same slope.
Okay. So Brendan said 2 over 3x, and Charlie said same slope. Are they really saying the same thing?
Yeah. Yes.
Yeah, because 2/3 is the slope. So I'm going to graph the first line in blue. So this one has a y-intercept of -5, 1, 2, 3, 4, 5, and a slope of 2/3. So up 2 over 3. And then I'm going to try and graph this with a straight line. So there's y equals 2/3 x minus 5. And then I'm going to graph y equals 2/3 x plus 1. I'll do that one in another color so I can differentiate. So my slope is 2/3, so up 2 over 3. And then I can go down 2 and 3 to the left to continue the pattern. So we know that algebraically, and in terms of looking at the equation, that they both have 2/3. But geometrically, in terms of the geometry, what is the relationship of the lines? Ashley?
They're parallel.
Yeah, so the lines are parallel. Can someone give me a definition of parallel? Can you say that one more time?
Two lines that never cross.
Good. Two lines that never cross or touch. They just run side by side each other. So, same slope are parallel. So, changing the y-intercept doesn't change how steep they are. They have the same steepness. The rise over the run is the same. These happen to have a slope of a half. Up 1 over 2. Up 1 over 2. They just happen to be located at different spots on the coordinate plane. This one has a y-intercept of -1. This one has a y-intercept of 3. Parallel lines have equal slopes. This is y equals 1/2 x, because the slope is a half, plus 3. Y equals 1/2 x minus 1. All right, and they're never going to cross because they're just going side by side. They're like train tracks, which hopefully those don't cross. That would be a rough ride. Questions on that? DJ?
If they were like on the same line, would that be parallel?
So if they were on the same line, what would be true about the equations?
They would be the same.
Yeah, and in that case, they wouldn't be parallel. They would be what's called coincident. Coincident means they're actually the same exact line, which means they're just one on top of another. So parallel lines have equal slopes. Equal lines also have equal slopes. Okay, so that's another case where they could have equal slopes and actually just be the same exact line. But that's called coincident. really that just means the same line. And that is very easy to spot if they're both in y-intercept form, slope-intercept form, because it'll just be the same thing. But if one's in slope-intercept form and one isn't, you can't really tell that they're the same. So we're going to experiment with that a little bit later. Let's look at these two lines. I'm going to graph this one. This one has a y-intercept of -4, so 1, 2, 3, 4 down. And then my slope is -3/2. So my rise is -3, my run is 2. So from here, I'm going to go down 3 and over 2. Up 3, up 3. Did I do that right? 1, 2, 3, over 2. 1, 2, 3, over 2. Okay. -4 is my y-intercept, and then down 3 and over 2. Down 3 and over 2 is my slope. This one has a y-intercept of 1, and my slope is 2/3. So up 2 over 3, up 2 over 3. I could also go down 2 over 3 in the other direction. Connect these dots. Well, we know those aren't parallel, right? What does it look like the relationship between the two lines are? Yeah, they do intersect, for sure. Do you see anything else about them? Isaac? Yeah, they are perpendicular. And they look more perpendicular if you move your head like this, but these are perpendicular lines.
Geometry.
So perpendicular means they meet at what angle?
Right, 90.
Yeah, 90-degree angle. I just want to give you a symbol. This is the symbol for perpendicular. It's like an upside down capital T, so you might see me using that a little bit.
Physics. Physics. That's what it's physics. That's our first exam. Get ready, kids.
Okay. Now, what is the relationship between the slopes of these lines? Are they equal?
No, they are turned around.
Yeah, they are up and
down.
That's my sister's favorite period. No, I want to sing it for so what do you mean by turn around, Charlie?
They are switched. It's flopped. It's different. Yeah, the rise and the run are different.
Okay, so the fractions are
Switch. Flip. Reciprocal.
reciprocals. Anything else?
Yeah, and the
One is negative and one is positive. So
Okay, what's your question?
It's still coming this way, it's not.
Ow. Say that again?
This like this, and that's what this is.
No, it has to be a 90-degree angle if it's perpendicular.
So to find that out, it should be the opposite. The reciprocal.
That is correct. So perpendicular lines have slopes that are opposite reciprocals. So let's take a look at these two lines. Who can tell me the slope of the orange line? DJ.
4 over 2 or 2 over 1.
Okay. Up 2 over 1. Who can tell me the slope of the purple line? Brenda? Okay, so here to here. You go down 1. No, same thing. It's the same thing. You were right. So the slope is -1 over 2. Are those, in fact, opposite reciprocals?
Yeah.
Well,
Oh, that cancels out.
not perfect.
You can.
Now, what do you mean by that, Denise?
Since you multiply them, they
If-
cancel each other out.
If you multiply them, what do you get?
Well, 2 over 2 over 1.
Okay, so not only can you think of them as being opposite reciprocals, you can also think about them as if you multiply the slopes together, or the product of the slopes, we can say it this way.
Wait, equal and opposite. Physics.
Would that be the same, saying that they're equal and opposite?
Not quite, they are opposite, but they are not equal.
Well, when you multiply them, one,
Are they one?
well, negative.
So the product of the slopes is -1. So if you have equal slopes, that means the lines are parallel. If you have opposite reciprocals, that means the lines are going to be perpendicular. Anything else, that just means the lines cross like, in any other way. So this is where it gets interesting. And for those of you who decided to opt out of writing examples down, who will remain unnamed, I really suggest you write these down. So let us write the equation of the line that goes through this point and is parallel to this line. These are, in my mind, some of the trickiest things you're going to do. So when it says it's parallel to this line, the only piece of information you need from this line is the slope. So can anyone tell me the slope of that line?
3.
How do you know?
Because it has the x.
Yes.
-0.5.
How do you know? What does that mean? What math did you do?
Well, I added -3 to the other side.
So what form are you putting it in?
Y equals mx plus 3.
So if you add -3x to both sides, you get -5y equals -3x plus 6. And the purpose of this, DJ, is what?
To get y1.
Divide by -5. So y equals, what, DJ?
3 over 5.
Yeah, it's going to be a positive 3/5 x plus -6/5. Now, again, what was the purpose of doing this, TJ?
To get y1.
To do what?
To find the slope.
To find the slope. The easiest way to find the slope of a line, if you're given the equation, is put it in slope-intercept form. If you put it in slope-intercept form, you can just grab the slope off of the coefficient of x. But we couldn't do that to begin with because it wasn't in the correct form. So if it was in the correct form, we could do it right away, but unfortunately, we had to get it in slope-intercept form. Now, this is where students get confused because they want to gather all the information from this line. But the only thing you need to know about this line is the slope, because it says it's parallel to this line. So that means it has the same slope as this line. So the slope of the line we want to find is 3/5. And it goes through the point that's given, 0, -6. So notice that -6/5, this is unnecessary information. because it's parallel to that line, but we don't care about that line's y-intercept. So the slope is 3/5 because it's parallel to the line that has a slope of 3/5. So there's my slope, and it goes through the point 0, -6. So I'm going to write y equals mx plus b. And then I'm going to substitute in my point 0, -6 and solve for b. -6 equals 3/5 times 0 plus b. Because I plug in this point. So these cancel out, and -6 equals b. Now, you don't get any points or full credit unless you actually write the equation. You have both parameters, though. You have the slope, and you have the y-intercept, but it's kind of like working all week and not cashing your paycheck. You have to fill in the numbers. This is the equation. The slope is 3/5. And how we found the slope is we put the equation that it's parallel to in slope-intercept form. And we just picked the slope off of that point, of that line. And then we found the equation of the line that had that as the slope and went through the given point. And that's my equation. Questions on that? Next one. Write the equation of a line through 0, 5, which is perpendicular to this line. Let's scroll up a little bit. So first step is to use this line. And the only thing I need from this line is the slope. Let me get some water. Need slope. So again, to find the slope, I have to put it in slope-intercept form. So I'm going to subtract x on both sides. Then I'll divide by 2 to get y by itself. Okay, so take a look at this. I needed the slope from this line. This line has a slope of -1/2. Is it parallel to this line or perpendicular to this line? Perpendicular. So this slope is -1/2. What's the slope of a line perpendicular to this? Yes. Close. Yep. 2. So the slope of the line is 2 because it's the opposite reciprocal. So you flip it over and you take the opposite of it. So now the slope is 2 and it goes through 0, 5. So it's like a new problem. The first part of the problem, you find the slope of the line. And then from that, we pick the slope off and we either keep it the same if it's parallel. If it's perpendicular, we take the opposite reciprocal. So y equals 2x plus b. We plug in our point. Two times 0 is 0. So 5 equals b. We're almost there. M equals 2, b equals 5. So y equals 2x plus 5. Yes.
So you did the -1/2 x over there, and then is that just when you have y equals 2x plus b? Is that the 2y, and then you brought the 2 over?
So what we had to do from here to here is we had to take the opposite reciprocal.
Okay,
And the reason we had to do that is because these were perpendicular. If they were equal, if they were parallel, you would keep it the same. If they're perpendicular, you have to take the opposite reciprocal of them.
okay, so then that case would be 2.
It is coincidental that this 2 is that 2.
Okay, so don't like look for that, okay,
Yeah, that sometimes will happen, but it's nothing to count on.
okay,
So if it says reciprocal, you flip the fraction upside down. So 1/2 becomes 2/1,
right.
and then you make it positive, you change the sign.
Oh, okay, right, okay, got it.
So,
Thank
Yeah.
you.
before you go to the next one, could you set up anything last part?
Is that enough, or any more?
Yeah.
More?
Using things.
So the moral of today's story is if you have two parallel lines, their slopes are equal. If you have perpendicular lines, the slopes are opposite reciprocals. And so it just adds a little more work to the problem. Other questions? Okay. So I'm going to modify your assignment slightly because I didn't get to these last couple.
Yeah.